Hi Senior Stage, it's Gail back with you again today. You're going to learn today about changing the subject of formulas and equations. Hold on a bit, the topic sounds really confusing. Changing the subject. You usually learn about subjects when you're studying English, and I think I should change this for now because this is a maths lesson. But you've learnt about subjects in English when you break up sentences into subject, verb and object. Weirdly enough, what we're going to do in maths is not very different, which I'll show you in a minute. And then what's with formulas and equations? What is the difference between formulas and equations? Well, really, there's no difference between them at all. Formulas are equations. We use them to represent situations that occur over and over again. We use the same formula for the same situation. Formulas are really maths models of problems that we ask to solve over and over again. Some examples are finding the area of a circle, or how much interest you earn on an investment, or what are the running costs of your car. Just from habit, we mostly use x's and y's in equations and other letters like A, B, and C in formula. This is not significant, it's just another strange habit of mathematicians. Let's go on to see what we mean by those words changing the subject. In the sentence, Jack loves chocolate, Jack is the subject, loves is the verb, and chocolate is the object. It is possible to make chocolate the subject of that sentence. Chocolate is loved by Jack. If you think of the equation y is equal to x plus 1, y is the subject, is equal to is the verb, and x plus 1 is the object. You need to change this around to making x the subject. So it is going to be x is equal to something over here. Fortunately, you've just been doing equations, and those are the skills you need to solve this problem. Here's the question. Change the subject to x. Your equation is y is equal to x plus 1. You need x to be by itself. The first thing you're going to do is subtract 1 on both sides. On the left side, you have y minus 1, and on the right-hand side, x plus 1 minus 1. That will leave you with, on the left-hand side, y minus 1 is equal to, and on the right-hand side, x plus 1 minus 1 is x, because plus 1 minus 1 is 0. We've actually finished. We've just got it the wrong way around. X is equal to y minus 1 is exactly the same thing. I'm going to go through a few examples with you. The question is make x the subject. Number 1, 3x plus 2 is equal to 1. So we need to get x by itself. The first thing to do is to subtract 2 from both sides. 3x plus 2 minus 2 is equal to 1 minus 2. On the left-hand side, you have 3x plus 2 minus 2 is 0. And on the right-hand side, you have negative 1. 1 minus 2 is negative 2. We're still looking for x by itself. We divide both sides by 3. 3 divided by 3 is 1. We have x is equal to, and on the right-hand side we have negative a third. You might be asking yourself how this is different from the other work that you've just been doing. And it isn't different at all. Making x the subject and saying solve for x is really the same thing. In number 2, 2y minus 4 is equal to 2x. We need to make x the subject and So what we are going to do is we're going to divide both sides of our equation by 2. It's each term on the left-hand side, 2y divided by 2 minus 4 divided by 2 is equal to 2x divided by 2. On the left-hand side, 2 divided by 2 is 1, so we have 1y. Minus 4 divided by 2 is 2. On the right-hand side is equal to 2 divided by 2 is 1x. And then write it the correct way around with x on the left. X is equal to y minus 2. Number 3. So this one's got a lot of letters in it, but it doesn't make any difference. You want to make x the subject of your formula. The first thing I need to do is subtract g from both sides. I have kx on the left-hand side plus g minus g is equal to m minus g. On the left-hand side, I just have kx plus g minus g gives me 0, and on the right-hand side I have m minus g. Now what I need to do to get x by itself is to divide by k, and if I divide by k on the left-hand side, I must divide each term on the right-hand side to keep the balance. So kx divided by k on the left-hand side, m divided by k minus g divided by k. K divided by k is 1x is equal to m divided by k minus g divided by k. Okay, so let's put the pressure on you a bit and start off with some fractions in this one. Remember, the question is that you must change the subject to x. On the left-hand side, the first thing I'm going to do is subtract g. And if I subtract g from this side, I must subtract it from the right-hand side. On the left-hand side, it's x over k plus g minus g is equal to, on the right-hand side, m minus g. On the left-hand side, I have x over k plus g minus g gives me 0, and on the right-hand side, I have m minus g. Now, how do I get rid of this k that is in the denominator? Well, I just need to multiply everything by k. So you multiply k over 1 multiplied by x over k. I make it k over 1 because there's a fraction there. And on the right-hand side, I don't have fractions, so I can just leave it as k. Multiply k times n minus k times g. On the left-hand side, k x over k gives me just x, because k divided by k is 1. On the right-hand side, km minus kg. That wasn't too bad, was it? The next question is phrased slightly differently, but the way you answer it is the same. It's make the letter in brackets the subject. You have A is equal to 1/2 BH. That's the area of a triangle, and you need to make H the subject. So you must solve for H. You already did this in the previous exercise, and you just didn't know that you were doing it. A is equal to 1/2 BH. If I want to get H by itself, I must get rid of the half and the B. I'm going to multiply both sides by 2 to get rid of the half. On the left-hand side, 2 times A is equal to, on the right-hand side, 2 times 1/2 BH. 2 times A is 2A. 2 times 1/2 is 1 BH. I'm trying to make H the subject of the formula, and so I must divide by B on both sides. On the left-hand side, it's 2A divided by B is equal to, on the right-hand side, BH divided by B. On the left-hand side, I have got 2A divided by B. I'm just going to go on here. 2A divided by B. And on the right-hand side, B divided by B is 1H. And then I have H is equal to 2A over B. Question 2. A is equal to pi r squared. You should recognize that as the formula for area of the circle, and you need to make the letter in brackets the subject, so we're changing the subject to r. I need to get r squared by itself, and so I'm going to divide both sides by pi. On the left-hand side, I have a divided by pi is equal to, and on the right-hand side, pi r squared divided by pi. On the left-hand side, a divided by pi, and on the right-hand side, pi divided by pi is 1, and so I have r squared. You've got r squared, not r, but how do you get rid of r squared? Do the opposite. You find the square root, and that will give you your answer. R is equal to the square root of a over pi. Question number 3. Q is equal to an over 1 plus b, and n must be the subject of your formula. So our n's really wrapped up at the top there. The first thing to do is to multiply both sides by 1 plus b, so I can get rid of my fraction. Left-hand side, q multiplied by 1 plus b is equal to an over 1 plus b multiplied by 1 plus b over 1. On the left-hand side, you have q multiplied by 1 plus b. And on the right-hand side, the 1 plus b's divide out and you're left with an. Now, I need just to get rid of the a, which is really easy. Divide both sides by a. On the left-hand side, I have q1 plus b divided by a, and is equal to, and on the right hand side, an divided by a. The left hand side is the answer. Q1 plus b over a is equal to, and on the right hand side, a divided by a is 1, and so I get n. And then, as we've done all the time, you write it the other way, n being the subject. N is equal to q1 plus b over a. What you've done today is not really new work. It's using your equation skills in a different context. You should be able to go on with the exercise.